Good morning, everyone, and welcome to the April Pacific Northwest Drought Early Warning System Drought Climate Outlook Webinar. Thank you to those that have joined us previously and to those joining for the first time. My name is Megan Dalton, and I'm with the Pacific Northwest Climate Impacts Research Consortium, or CIRC. This bi-monthly webinar series is hosted by NIDIS, CIRC, and the Northwest Climate Hub. It's designed to provide stakeholders in the Pacific Northwest with timely drought and climate information. Each webinar is tailored to reflect recent, current, and forecasted conditions and climatic events, and also includes discussions of observed impacts and other relevant updates from across the region. A recording of this webinar will be posted on drought.gov later this week. And just a note that after today's webinar, you'll have the opportunity to provide feedback that will help us improve the series. So please take a moment to tell us what you think. So today's speakers include Nicholas Bond, Washington State climatologist, who will present a climate recap and current conditions. Then Andrea Baer with the National Weather Service Western Region Office will present the climate outlook. And then next we have Kathy Dello with CIRC, who will speak about the results of a project to develop a new total moisture drought metric. And then finally we have Kyle Hobrief with Oregon State University, who will present his research on predicting vegetative response to precipitation and grazing intensity. So please use the chat box to ask any questions during the presentation, and we'll address them at the end. So before we move into the presentations, we'll highlight the partners that make this webinar series happen. First, the Pacific Northwest Climate Impacts Research Consortium, or CIRC, is a climate science to climate action team funded by NOAA's Regional Integrated Sciences and Assessments Program. CIRC supports communities, policymakers, and resource managers in Oregon, Washington, and Idaho, and Western Montana as they work to adapt to the changing climate. Next, the Northwest Climate Hub develops and delivers science-based technologies and practical information that will assist agricultural and natural resource managers with climate-informed decision-making. And then to highlight NIDIS, I'll turn it over to Britt Parker, the Pacific Northwest DEWS coordinator.
Thank you, Megan. So this is Britt Parker with NOAA National Integrated Drought Information System. And as Megan indicated, I'm the Regional Drought Information Coordinator for the Pacific Northwest and the Missouri River Basin DEWS. So NIDIS's mission is to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. So we want to improve our understanding of how and why drought affects society, the economy, and the environment, and improve accessibility, dissemination, and use of early warning information for drought risk management. Our approach is to achieve this goal is to build on a foundation of national drought early warning through the development of regional DEWS, or drought early warning systems, where networks of partners and stakeholders share information and actions that help communities cope with drought. While the ultimate goal is national drought early warning, we recognize that impacts and early warning information differ across the regions. Each DEWS has many of the same base ingredients, but ultimately have their own flavor to reflect the needs of their region. The Pacific Northwest DEWS was officially launched in February of 2016, and the strategic plan for the region is available on drought.gov. So mark your calendars. Our next Drought and Climate Outlook webinar will be on June 24th of 2019. And as our first speaker gets ready, I just want to highlight CocoRoss to facilitate our early warning system. More precipitation observations are needed. So we encourage you to join CocoRoss, the Community Collaborative Rain, Hail, and Snow Network. This is a unique nonprofit community-based network of volunteers of all ages and backgrounds working together to measure and map precipitation, rain, hail, and snow, as well as condition of reporting. Observations by CocoRoss observers of precipitation events or lack of precipitation are important to capture and improve our understanding of our weather. Here are your CocoRoss coordinators for the different states, and I'll post this in the chat box as we move forward. But at this point, I will turn it over to our first speaker.
All right, we'll have Nick Bond present the climate recap.
Hello, everyone, and I'm flattered to be able to run the first leg here of this relay race. And and cover the regional climate conditions in the Pacific Northwest, following the lead of Karen Babak, who did it a couple of months ago. And so following her sort of model for that, and leading off with, and why does not show my screen here? There we go. Leading off with, well, now I have to apologize. I don't have control, apparently. Do people see a slide called regional climate conditions?
We
do.
See
that first.
Yeah, for reasons that I'm unclear, I'm not able to advance it.
Let me try one more time here, Nick.
Yeah, okay. There we go. I think we're in good shape here now. Now you should be seeing the 2019 water year, October through March.
We are not yet seeing your presentation.
Oh, okay. Yeah.
We just tested it and it all worked. But of course,
right.
There we go. Okay, here we go. Yep, we see it.
Yeah. And so I'm going to go I cannot control my presentation though.
Okay. I'll do it for you from here if that's okay.
Yeah, that's right. Odd. Okay. Yeah, well, first time this has ever happened.
Hold on, I'm sorry. You're looking at, there we go. Sorry about that, folks.
Yeah.
There we go. Okay.
And again, the regional climate conditions, and going to race through this. And so just like I did 2 months ago, I'm going to start off kind of big picture, the first 6 months of the water year. On the left is the mean temperature in anomaly form, October through March. On the right is the precipitation in terms of percent of normal. And notice all the blues there in the temperature plot. That is something we haven't seen too often in the last few years, but especially the Columbia Basin, Eastern Oregon, and parts of Western Montana, colder than normal. It was, for the whole historical record, not that unusual, but definitely for the last 30 years on the cold side. In terms of precipitation, you can see some welcome heavier than normal precipitation in Eastern Oregon, Western Montana, and the Snake River Valley, dry on the west side of the Cascades. Next slide. Let's look at, a little closer in the recent past, to March, and a little bit of a microcosm for the water year as a whole, where it was considerably colder than normal in parts of the Northwest, particularly the Columbia Basin, and kind of in the Northern Rockies. Very dry, though, with the exception of parts of Eastern Oregon, and in particular the northwest part of Washington State in terms of percentage of normal was exceedingly dry. And I'll hit on the kind of north central part of Washington State as part of the, one of our real problems. Okay, next slide. Now, just looking from 2 weeks ago, going back from late last week, there some improvement in terms of precipitation for the west of the Cascades, with showing above normal temperature precipitation, the panel on the right, and temperatures a little bit on the warm side. My lettuce and spinach is going great guns, and so welcome news there. And but there's still a kind of a dry area there in the north central part of Washington State. So next slide. We like to kind of try to put this in the context of what was happening in terms of the weather patterns. And this, I chose just the month-and-a-half period from the start of March through the middle of April. This is a 500 hectopascal geopotential height anomaly map showing a high to the north, a low offshore of California. The implied flow in this configuration is more flow from the east than usual. In other words, less flow off the Pacific than usual. And that is, so less mild Pacific air has gone into the interior of the Pacific Northwest. And especially that less Pacific air has meant less precipitation on the windward flanks of the Cascades, so for the western part of Oregon and Washington for the whole. All right, next slide. But there has been some water problems in Oregon. The map in the upper left shows the stream flows over the weekend, with the blue dot showing much above normal stream flows. And there's a few black ones there showing, really high ones. There was the photo in the upper right is from Salem in the Willamette Valley a couple of weeks ago, showing some, moderate flooding there. The lower right photo is from the La Grande River in northeastern Oregon, showing some flooding occurring there. So some water problems, too much water in some parts of the Northwest. Next slide. From the snowpack point of view, as of a couple of days ago, Oregon is, especially eastern Oregon, in great shape. The kind of west slopes of the Rockies are generally in good shape. And again, the yellows and browns there showing below normal snow water equivalent for the time of year are mostly in Washington State. And next map. Kind of an overall perspective there is shown in this 4-panel figure where the precipitation, again, for the water year up to a couple of days ago is in the upper left. Soil moisture, kind of an instantaneous one last week, upper right. Some reservoir and stream flow indications in the lower left and lower right, respectively. And, just to repeat what I've been saying before, kind of dry on the west side of the Cascades, especially in Washington, and some dry there in the north central part of the state. And so that's seen in both the stream flows. I don't think the reservoirs are too meaningful in this case because there's still in the process of filling them just seasonally. So next slide. From an overall perspective, here's the latest drought monitor. There's been some improvement over the Northwest over the course of the winter, with the region that is abnormally dry mostly restricted to Washington State, except for the southeast corner of it. And the only part that's really in moderate drought is there in the north central portion, where look to have less than 75% of normal stream flows and probably some hardship in some of the watersheds in that region. So if we go to the last slide, just to kind of sum up, water year temperatures have been near normal, mostly west of the Cascades, cold inland, mostly because of what's happened at the end of the water or the end of the winter so far. Water year precipitation mostly below normal on the west side and above normal in eastern Oregon and the kind of interior Northwest. Mentioned some of the high stream flows and flooding recently. And overall drought conditions have generally eased, but it's the north central portion of Washington State that is the area of greatest concern right now. So thanks, and I'll be turning it over to Andrea, and apologies for the hiccups with the technology, but there you go.
All right, thank you, Nick. Why don't we turn it over to Andrea Baer for the Climate Outlook.
Okay, thank you, Megan. Are we seeing my screen?
Yes.
Okay, thanks very much. Good morning, everyone. I'm going to give you a quick look at the climate and the drought outlooks coming out of the Climate Prediction Center in NOAA. And there we go. I'm going to start out and give you the summary at the beginning and at the end. But basically right now, El Nino conditions, I'm sorry, this should say El Nino conditions are present. We do have an El Nino advisory right now, and the sea surface temperatures across most of the Pacific Ocean are above average, just slightly above the threshold of that 0.5 degrees C. And the rain and the convection cloudiness near the date line, there is some of that going on, and the winds that we expect during El Nino are there, which are a slackening of the trade winds and more of a westerly wind burst type situation. We have had that going on as well, but more consistent with a weak El Nino. So basically, the atmosphere and the ocean are coupled together and consistent with what we would expect for a weak El Nino. The forecasters are expecting El Nino to continue through this summer and possibly into fall of next year, or later this year. So current conditions right now, these are weekly sea surface temperature departures in this sweet spot right here we call Niño 3.4, and I'll just show you this graphic right here. This gives you a nice example of what's been going on over the past year with sea surface temperatures there, and you can see we really started ramping up in the fall and took a dip in January, and then as we got into February, we started to go back up with our sea surface temperatures. And again, we're looking for about 0.5 here in this region to call it an El Nino. So over the past month, the sea surface temperatures near the equator have been above average in the Central Pacific here. Here's the date line. So in the Central Pacific and also farther east in the Eastern Pacific. And then around Indonesia and the farther parts of the Eastern Pacific, you can see this area here a bit on the cooler side. As far as the subsurface ocean goes, so down from the surface about 300 meters, you can see it's been pretty warm for the whole year, basically, for the past year. And again, in that last graphic I showed you, this is somewhat similar. In September, we started ramping up pretty warm and then cooling off a little bit in the subsurface, and then again ramping up as we got into February and cooling off as we're getting later into April. This shows you a different view of what I just said. If we go back to May last year, we started seeing those warm, this is indicative of those, it's basically a Kelvin wave. So it's a wave of warm water that moves across the Pacific Basin. It's a basin-wide wave, and this shows it traversing across the ocean. This is the date line here. And this is time, so this is last May, and this is currently April. So you can see we've had several phases of when these Kelvin waves have moved through and made those subsurface waters warm. We had a bit of a cool off that started in December and into January, but then again we had another Kelvin wave move through, and you could see that moving into the end of March, and then now cooling off a bit. And this is a complicated pattern, but what I want to show you is basically right here. Actually, I'm going to start here. So January through February, we did have these westerly wind anomalies, which are the orange colors here, and they started picking up around the date line area. So that just means that that's more what we typically expect during an El Nino situation. Since March happened and moving into April, those have obviously in that sweet spot of right around the date line, those have gone to a more easterly component, and the westerlies have shifted more to the western side of the date line. So things are calming down, but expected to continue. This is the forecast that the Climate Prediction Center and the International Research Institute jointly put out. And I do want to say, and I'm going to say this again, but climate models are quite unreliable when making seasonal predictions from about definitely March and April, but also continuing into May. So not a lot of confidence on the forecaster's part during this time of year when looking forward, but nonetheless, El Nino is the red bar here, and it does look to continue through into the fall. Again, I wouldn't put a ton of stock into that because, like I said, models are notoriously unreliable this time of year, but it is something to keep an eye on and something to be attuned to. So more on that as we move out of this spring barrier or this time when the models are quite unreliable. Here's another view of the models. Majority of the models, both dynamical models and the statistical models, are showing El Nino to continue basically right as we move into fall. So we'll see if that really happens. Here's that sweet spot right here, the threshold that we look at. There's the minimum threshold for El Nino. So just a majority of them just above that, all through the summer and into the fall. So this is the 1 month outlook for temperature and the 3 month outlook for temperature. And again, I want to emphasize models are unreliable at this time of year. So again, don't put too much faith in this, but I'm going to show you a couple of other things to look at on the shorter time scale that probably would be better tools to look at for this time of year. But basically, above normal favored for much of the Pacific Northwest, and that's for May. And then for May, June, and July for the seasonal forecast, also for actually much of the entire western U.S. And a little bit more confidence that those temperatures will be above normal right there along the coast of western Washington and northwestern Oregon. Looking at temperature, for May, below normal is slightly favored. Again, there's definitely odds for it to be near normal or above normal, but it's slightly favored to be below normal up there in western Washington and far northwestern Oregon. And then also looks similar for the 3 month forecast for May, June, and July. I actually, if you go onto the Climate Prediction Center's webpage, which there are links all through this presentation, if you look at the interactive display for the week 2 forecast, this might be something better to continually look at. It's updated daily, and this basically shows you, I just picked Spokane, you can type in your location, and it shows you that for that area in Washington, below normal temperatures are expected, or favored, excuse me, not expected, but favored, and really not much to say about the precipitation in that area. Maybe just a slight favoring, but not much. A little more confidence in favoring below normal as you move into this area of the southwest part of Washington. But you can get those from going here, or you can get the traditional way of looking at those by going to temperature and precipitation there. You can also look at the 8 to 14 day hazards outlook. It's right here on this, again, same area on the Climate Prediction Center webpage. You can get a composite of the temperatures, the precipitation, and the winds here. It'll put it all on one map, or you can get each individual map by clicking here. And the composite only shows if we have moderate confidence for an area. All of these areas that are shown here are just slight confidence, so just something to keep an eye on, but slight confidence for winds basically east of the area we're talking about for this call, but really nothing for the Pacific Northwest. But this is something to keep an eye on. Again, it's updated daily, so I would actually look at these types of things more so than the seasonal or monthly right now. And then the seasonal drought outlook looks like drought development is likely for, a lot of this area already is, as Nick just showed, but continuing to persist in this area here and likely to develop for these areas here for the next 3 months. And that would be for May, June, and July. And so with that, I will leave you with my summary slide and pass it back to you guys. Thank you.
All right, thank you, Andrea. We did have a quick question about whether some of the websites that you mentioned from the Climate Prediction Center would be available, and perhaps you might be able to put those in the chat box for folks.
Yes, I can put those in the chat box. They're right here as well, but yeah, I'll put an easier one in the chat box. Yes.
Okay, or Britt can help with that as well.
Yeah, thank you.
Thank you, Andrea. So now we will turn it over to Kathy Dello. Great, can you see anything? Almost. Okay. There it is. Great. Well, thank you, everybody. It's really great to join these webinars again. I once played a role in them a few years ago, and Megan is doing a far better job than I ever did. For those of you who don't know me, I'm Kathy Dello. I'm with the Climate Impacts Research Consortium. And I'm going to talk briefly about a project that we did with some NIDIS funding. And this work is mostly that of a graduate student, Danielle Maruzzi. And the great thing about graduate students is that they sit down and do great work for a few years. The bad thing is that they leave us and you get the third string talking about their work. So I'm going to try to do this work justice, but if you have any questions afterward that I can't answer, we'll be sure to find you the right answer from Danielle. What? Another thing. Oh, I lost my. Is it just blank?
It's yeah. We're going back to what we usually see during transition. Let me take it back and then give it back to you again and see if we can restart it. Hold on one second.
Okay.
Must be a Monday. Okay, it should be coming back to you. See if that'll work.
Technology. There we go. There we are. Okay. So why do we need to talk about drought recovery when we have all sorts of drought metrics that are out there? I mean, we talk about things like the Palmer Drought Severity Index, the Standardized Precipitation Index, we have U.S. Drought Monitor. It's almost mind-boggling, and I have researched drought for a number of years, and it's still difficult for me. And one of the things that we decided, and this came out of a NIDIS meeting that happened in Boise with a number of folks who are probably on the phone, is that we really needed to understand more about the triggers of drought and the indicators of drought here in the Northwest. And the slide that Andrea showed at the end of the Drought Outlook is, you know, a great product that NOAA's putting together, but it's really nationally focused, and we needed something with a little bit more local granularity based around the decisions we have to make in the Pacific Northwest. And one of the things we heard loud and clear is that we need to think about drought on variable timescales here, even though we have our climatological drought where we have the wet winters followed by the dry summers. We kind of need to look at this in different time slices. And then looking at more of the future outlook for recovery here, at least in Oregon especially, we tend to be very optimistic and see bad conditions evolving over the winter and sometimes think, well, it's going to get better. And this year it certainly did, but sometimes it doesn't, and often it doesn't. So what we wanted to do is figure out a way to quantify this a little bit better with some of the tools that we have in CIRC. The research that we do always involves people who are making actual decisions. We don't just ask scientific questions for the sake of science. And like I said, this came out of a meeting that happened in Boise a number of years ago, but what we did is we went back to the state drought coordinators in Washington, Oregon, and Idaho,
That's Jeff Marty in Washington, Ken Starr in Oregon, and David Hokema in Idaho. And we sat down and said, hey, we're thinking through this project and we want to cut off the first piece. Ideally, what would you need? And some of the intro that I teed up there is what we heard, but really we wanted to get a better handle on recovery, and we wanted to figure this out at least by county. Each of the states defines drought differently. Each of the state has different mechanisms for declaring drought, but a lot of information is disseminated out through counties, and in Oregon at least, the drought declarations come up through the counties. And on a longer webinar, I could explain that a little bit more. But we had that first discussion with them, and we sent Danielle away to basically generate what we thought we heard, develop this initial metric with some of the guidelines from the stakeholders. We got the folks back on the phone around the webinar, and we said, here's what we thought you wanted, here's what we thought. We heard from you, does this look good, is this useful? So what we have here is really a cyclical process, and this goes around a number of times. We presented it to them. They said, this is good, but can you tweak this? Maybe think about a different starting date. That color doesn't look good. Really, just sort of anything. We really want this research to be useful. So we went around a few times, and what we have here is the final product is essentially Danielle's master's thesis, but there's some talk about going around the loop again. The kind of work that we do with stakeholders can kind of constantly evolve until we settle on something that we think is useful for them. So how we did this is that we used the variable infiltration capacity model, or VIC, which is a tool that we use here in CERC and goes into our Northwest Climate Toolbox. And we decided to generate total moisture, which is already generated in VIC, for the historical period of 1920 to 2015. Really, all we're doing here is just understanding the historical probability of recovery. And we chose soil moisture and snow water equivalent because not every basin in the Northwest is snow water dominated. Some of it is more transitional, and soil moisture plays a really key role, even if there is a big snowpack in thinking about drought in the summer. So what we landed on is total moisture as the metric that we're using. And we certainly didn't invent this, but we're thinking about new ways to display it so that it's useful for decision making. So what Danielle did, and I'm just showing Oregon here, is that we heard from our stakeholders that February was really a crucial time for trying to understand where we might be for summertime water supply. Should we be anticipating drought declarations? Should we be anticipating water shortages? How do we message that to the counties and the water managers and the people who may have to deal with this in the summer? So what we decided on is that the 25th percentile, and she played around with a lot of this, was where we were going to start on February 1 with this total moisture metric. And what you're seeing here are the Oregon counties and where they were in 2015, February 2015, which we know was a huge drought year in the Pacific Northwest. And what you see on the right panel is the probability of recovery. And what we're defining as recovery is above the 50th percentile by July 1. So what she's done here is just taken a look at the counties and seeing how often would we recover when you're at this threshold by July. And you can see that the coastal counties have a much higher probability of recovery thanks to the variability of precipitation and spring rains. But there are some counties, especially in the more arid parts of the state, which when you've bought into drought by February, it's really tough to see recovery. They almost often never recover, and some of the counties saw no recovery in the historical period. So this is really useful information for us rather than thinking about, oh, it may recover, kind of focusing on these areas where it doesn't often recover and thinking about maybe targeting some resources there. I just pulled up the total moisture percentile for the other day. This is Saturday, and you can see even though despite the rain that we had and the snow that we had and the flooding we had around the region, there are still areas of the Pacific Northwest which correspond well with what Nick pointed out that are still struggling with total moisture percentile. And these areas were also below the 25th percentile in February. So even though we had a miracle February, early March, we're still going to probably see some problem areas around the region this summer. We have a lot more work to do. Even though Danielle's moved on, we're committed to taking this a little bit further, looking at some more time slices, continuing refining the outputs to look less wonky and be more user-friendly, maybe to county emergency managers. And we are writing a paper on kind of the process that we went through, because really the drought coordinators of the 3 states were such key partners, and this project went in a completely different direction than it would have if we had just came up with the questions ourselves. So that's just a quick overview. Thanks again to NIDIS for the funding, and CERC and OCRI as well. And my PowerPoint is going to crash, so it's about time to turn this over to Megan.
All right, thank you, Kathy. So our final speaker is going to be Kyle. We're having a little bit of some technical difficulty, as many have had today. So we're going to actually have to unmute everybody so we can get Kyle to be on the phone. But please, once you're unmuted, if you're not Kyle, please mute yourself so that we can, all of you are Kyle. So go ahead, Britt, when you're ready.
Okay. So I've unmuted all. Kyle, can you speak, and let's see if this is going to work and if we can hear you. Okay. Sadly, we may end up having to reschedule Kyle's talk. He's had some technical difficulties, even with all the tests going into the webinar, and can't access the GoToWebinar. So we were hoping he could call in and I could just run through his slides for him, but it looks like that's not going to work.
Brett, it doesn't look as though everybody is unmuted.
Okay. Okay. Can you still hear me, Megan?
I can hear you, Brett. Yeah.
Okay. Yeah, so it looks like because we have so many participants on the line, it won't allow me to unmute all. So I think, Megan, if you want to just proceed with
Sure.
any other questions that have come on, we'll have to work with Kyle and see if we can reschedule. My apologies.
Can people hear me now?
Oh, yes, we can.
Yes, we can hear you, Kyle.
Excellent.
I just figured the audio out. The code was buried in the email, so I'm
Okay.
sorry. I'm so
Okay,
sorry
so-
that I'm so late.
The floor is yours, Kyle.
Oh boy, then. I guess I was just in the nick of time. I believe our fallback here is Britt
Yep.
is to run through the slides for me.
Yes.
Okay, boy. Well, I'm glad I was able to make it audioly here, and I'm glad Britt has my slides of my PowerPoint presentation, which is about using models to go from models to management. And as my title shows there, the nuts and the bolts of what we're trying to get at is predicting plant response to precipitation and grazing intensity, so that we can manage the short and long-term risks associated with drought. The primary vulnerability there being forage production on range livestock. Quick overview. I'm going to do a fast run through of what rangelands are and then the risks that they're facing these days, with a particular focus, and that'll be pretty quick. And then I'll move on to the practical information that we're working on getting out of models these days. So I'll give a quick credit here to the USDA Climate Hubs for the funding for this research, and all of our local and national collaborators you see there on the lower right of the slide. Excuse my dry mouth there. So rangelands, definition of rangelands. In a nutshell, this definition that you see there on the slide, to me, describes a social ecological system where the ecology of it's dominated by vegetation as described there. And with the main productivity purpose seems to be of that system with regard to rangelands and livestock production is providing fodder for cattle. And due to increased global demands for food productions from rangelands and changes in management policy over the last 100 or so years, happening in different time frames in different parts of the world, there's increased stress on rangelands that are really being exacerbated by climate change, all of which is resulting in declines in the ecological integrity of rangeland habitats and the well-being of the social systems involved in those rangelands. And as you can see there, there's some, I actually just started up my PowerPoint slide so I can follow where I'm actually going there. And as you can see there in the pictures, there's many potential types of rangelands. Of course, here in the U.S. West and the Pacific Northwest, we're most used to what's there on the left-hand part of the slide. But rangelands do include a forested component oftenly, and they take many different manifestations around the world. And transitioning away from those slides of different rangelands, we see a box on the left that summarizes the actual different climate change risks or risk variables that occur. Now, globally, those risk variables vary. So I've thrown out some examples here that frequently come up in the Pacific Northwest, being increased temperatures, which have an add-on effect with some of these others here. With temperatures going up, there's also increased growing season lengths and changes in precipitation and snowmelt patterns. Now that graph to the right is just a quick visual description of that third issue there, where the dotted line is the typical daily precipitation, which over on the left-hand side of the graph there falls as snow. And then the precipitation decreases into the summer months and goes up into the fall a little bit more. And then the dark line you see is the actual runoff from mountain systems that feed water to agriculture downhill. One of the big things that's happening there with those increased growing season lengths and higher temperatures, a lot of that precipitation that used to fall as snow is falling as rain, leading to less runoff during the summers. Now that's not drought per se, but in systems like that are very typical to the Pacific Northwest, when drought does occur, it can really exacerbate those the lack of water during that summer season, particularly when the growing season is getting longer. I apologize for missing the first part of the presentation of the series. I was really looking forward to it, but as I understand it, other drought early warning system options were presented. And so if one of these DEWS predicts a drought, what can ranchers and other rangeland resource managers do to reduce their vulnerability? Now, a couple words on vulnerability there. Primary vulnerability of livestock producers during drought or any of those other climate risk variables is their ability to feed livestock off of the natural forage provided by rangeland habitats as moisture decreases. Advancing through the slide pop-ups there, the short-term impacts, of course, are if cattle don't get enough food, they die, and that decreases ranch profit. It has ongoing effects, decreasing the quality of life in rangeland social ecological systems and the community stability of those systems. And then you also have, advancing a bit more, long-term impacts, where coping efforts to deal with the short term lead to overgrazing or further ecological degradation that reduce future forage supplies and worsening the economic and social decline. Now, the picture there below the long-term impacts is just a quick image to show what kind of a really important factor is there with the potential overgrazing when drought occurs. And rangeland folks are kind of used to the rule of thumb of leave half hay calf, meaning leave at least 50% of your above ground biomass there. Now there's a huge variety there, of course, between different species, but you know, the essence of it is leaving above ground biomass so that your roots grow, so that it supports, again, the above ground biomass in a positive cycle where litter falls and increases organic matter in the soils and such. Now, the key adaptation information with the final pop-up on the slide that comes in the lower left to help manage impacts are the forage location and amount and the timing of that forage availability during the growing season. And then in a long-term sense, I was talking about the ecological impacts of both the drought and the stocking rate and the grazing to the long-term ecological capacity of those range and habitats. So moving on to the next slide, let's talk about the two models that we're proposing to address increasing adaptive capacity to meet those vulnerabilities. And the first is the PHYGROW Livestock Early Warning System, the Phytomass Growth Model Livestock Early Warning System. Quick word on what it does is that it uses information from satellites, both weather forecasts from the National Weather Service and from the Landsat satellite system. It uses a series, it uses a couple of different potential vegetation indices that demonstrate the productivity of vegetation across the landscape. So it integrates those computer and model data with management records in a database and information that comes from ranchers about their stocking rate. And it also accounts for the variability in the terrain and how that actually affects water availability once it falls to the ground as precipitation. And it also addresses the different species responses in forage growth in response to that available water in the soil. So it's a pretty dynamic model. And in doing that, it creates forecasts of the quantity of forage available across the landscape. And it does that in real time. So it'll give you how much data or it'll give you an estimate of how much range biomass or vegetative biomass is on the range today versus, it'll give you an estimate, it'll give you an estimate today based on yesterday's data, but it can also reach out for 3 months ahead of time to provide forecasts of what will be available. And we can provide that data on a weekly time step out or on a monthly time step out to 90 days based on the weather forecasts that reach that far. So the risk management role of this tool, as we see it, is the reduction of vulnerability by through short-term drought adaptation and increasing ranchers' ability or rangeland managers' ability to provide food for the livestock while not overgrazing. Now, the main methodologies for doing that might be to move from one place where the forage isn't good to a place where it might be better based on the maps. Now, there's certainly, as for those of us familiar with the U.S. Forest Service grazing allotment system, there's certainly some institutional boundaries to actually moving that way. So some other, within fences and such. So some other options there might be to use the forecasts of how much forage will be available to adjust herd numbers, or think about the composition of your herd so that it might be a bit more amenable to the drought conditions. And it also, and this is one of the more, I guess, a less intuitive piece of it to me, but in talking to ranchers out in Wallowa County, one of the ways they'd really like to use it is to maximize their offtake, but minimize their impact, so that they can maybe have that 10 or 20 or extra 100 head of cattle on the range, but because they're getting really precise estimates and forecasts of how much biomass is out there, they can increase that herd size without increasing their impact. You know, as far as getting this model implemented out in Wallowa, this map here, the next map that shows up as we advance, shows the sites that I've been to over the field surveys during 2017 and 2018, and made it to 109 sites around Wallowa County. And we're going to have forecasts coming out with the model in June so that our collaborating ranchers can use that to help their decision making out in Wallowa County this summer. And then moving on to the next slide, we're move to the land trender model, which land trender stands for the Landsat-based detection of trends in disturbance and recovery. And how that model works is that it uses recent advances in computer technology and cloud storage using Google Earth Engine, which stores the entire archive of Landsat satellite imagery for the last years and allows virtually simultaneous access to all that data so that you can do time series analyses and produce maps of habitat ecological change across the landscape over time and actually map the trends in those changes. And that's what you see in the lower right there, where the dots going across kind of the floating figure there represent readings of a vegetation index. This is probably NDVI if you're into those things. And the solid line is actually mapping the trend of all those data points, where you see that the first habitat state is evergreen forest, then it gets clear cut, which are the red splotches behind, and then there's a period of regrowth and then slower regrowth. That's the respectively the orange and yellows there. And what we'll be doing is converting land trender. It was originated in forest habitats to look at forest habitat change. So part of my PhD work is to adapt it to rangelands and use it for risk management role there, which its map and analyses with those maps to reduce the vulnerability to long-term drought by being able to avoid long-term ecological impacts due to management that reduce forage quantity and quality over time. And what you see in the yellow and brown map there with the graph off to the lower left of it is some land trender output. And to just explain their key really quickly, this is all out in open rangeland on the Sumwalt Prairie in Wallowa County. And dark brown colors indicate overall trends of gain in biomass over time, whereas the lighter colors are losses in biomass. And as related to drought, well, I guess I'm going to take a step back. I would say that the overall trend that's shown in this mapping that I did in Wallowa County is not actually mapping impacts of drought, but it's actually showing in the predominant biomass increase around there. We need to tease it apart, but it's either just biomass increase as a rebound from historical overgrazing. There's a potential that it's that. I actually suspect it's increasing predominance of annual invasives, grass species in the prairie out there. And what we're seeing in the lighter colors, note as you look around, the dark lines are actually tax lot boundaries that indicate property lines. And the highlighted ones are just some particular collaborators I was working with to collect data. But note that within many of the dark boxes and lines, there's stark differences in the biomass trends, even to neighboring properties. And even within some of those
Kyle,
lines.
Sorry to interrupt. We're getting towards the end of the hour. If you can finish up in a minute, then we can get questions.
Yeah, I can wrap up real quick here. So my main point there is long-term adaptation by paying attention to trends in biomass over time that are reductions. And so in summary, droughts are the primary climate change risk factor for ranchers and other rangeland resource managers. And the solution to that is accurate and timely information from computer models to reduce the vulnerability of those producers in their impact on forage provision to livestock. PHYGROW LEWS can help manage those short-term risks with its 0 to 90-day forecasts. Land Trender can help manage the longer-term risks by seeing what's been happening on different properties in response to variable management styles and trying to sort out the cause and effect associations there. And the new frontiers are looking at how these models actually complement each other in enhancing adaptive capacity and managing risk, and then integrating local and place-based knowledge with information from these models to improve their applicability on a local scale. And we have a suite of methods we're using there that's referred to as community-based observer network methods that we're beginning to employ. And that's my summary slide, and the last one is my thank you slide with a pretty picture of the Zumwalt Prairie looking down into Hell's Canyon. Thank you very much.
All right, thank you, Kyle. So if anybody has any questions, please feel free now to type them into the question box or the chat box, and we can ask them to any of the 4 speakers from today. We have just a few minutes. If nobody has questions, we'll end a little bit early. Okay, I see a hand raised. Let's see, Amelia Marchand, I've unmuted you. You had your hand raised? Okay, so the question was, can I get a copy of Kyle's slides? So Kyle, if you're amenable, you can go ahead and send them to Britt, and Britt can connect with Amelia Marchand afterwards to get slides to her.
Yeah, that would be great. I sent my slides to, as long as I didn't have any technical issues, sent my slides to Britt earlier today, so those should be at her fingertips.
Yep, will do.
Thank you. Okay, any other questions before we close up? All right, well, I will give you a few minutes to your hour, and reach out to Britt Parker if you have any questions and need to connect with any of the speakers. And again, a recording of this webinar will be posted later this week on drought.gov. Thanks everybody for joining us today.